So today, it's factored form. I'm going to jump right to the point. This one is not in factored form. This is called standard form.
Oh.
Did you just crash into a Tesla? I hope not. Okay. So, I would definitely lose to the snowplow. That is called standard form. Would you please factor it? Now, I know some of you are like, I don't even know what you mean. You put it two parentheses like this. And I made this problem up because I know it factors nice. This one will work. And I have made this bold statement before. This, out of the whole basics thing that I keep doing, reviewing basics, you learned this in algebra. And it was the number one thing you need for future math. So if you have been bad at factoring before, you're not allowed to just say, oh, I'm terrible at factoring. That would be kind of like saying, I'm terrible at reading. Well, fix it. Get better at reading. Practice it. Okay, so if you're terrible at factoring, you could have been terrible up till now, but you need to fix that now because you've got to get factoring. Because when you eventually get to pre-calc, which all of you are pretty much going to have to get through pre-calc, maybe you aren't taking it next year because only the top students will take it next year. But maybe you're taking it the year after that, you're going to be factoring like this all the time. Okay, so everybody put an X there and there. Because watch what happens. X times X makes X squared. See how that times that makes that. Next, I have to figure out what signs to put here. Now, I just want you to use logic for a second. If I put a plus here and a plus here, do you get that I could never get a negative to come out? If I only use positive numbers, there's no way to get a negative. Do you get that my problem has a negative? So by logic, do you get I have to have at least one negative sign? Do you get how that works? There must be one negative, so we'll make one of them negative. Now, why don't I make two of them negative? Again, you can use logic. If I used two negatives, then this would have had to be a positive. Do you get if there was a negative times a negative, I would get a positive number here? So I need one negative and one positive. Okay, so step two is the signs. Do you get? I now have signs in place. I have a plus and I have a minus. You with me? Yeah. Okay, last but not least is this number. And this is where a lot of you, your teacher gave you this shortcut that only works sometimes. It does work sometimes, but only works sometimes. And so some of you are like, well, I know that there's something about adding and something about multiplying here. I want to keep your life simpler. We're only going to say that these two numbers here and here need to multiply to 7. That's it. They just have to multiply to 7. Don't think about what it adds to, just multiply. Okay? Because the reason is when you get to the more advanced factoring things, they won't add up to this anyways. So it actually goofs you up more to think it's adding and multiplying because it's not. It's just about multiplying to this number. So how do I multiply to negative 7? It's got to be a 7 and a 1. But where does it go? Just guess. Seriously, just guess. Do you feel like it's going to be on the left or the right? Just take a lucky guess. Because we have to check it anyways. I'm just guessing. I don't even know if I did it right. I really don't. I didn't even think about it. I just slapped in a 7 and a 1. Because 7 times 1 makes 7. Okay, now I get to find out, did I do it right? And here's how you check. The first is this times this. X times X makes X squared. Yay, I got that right. And then, this is important, the outside and the inside, I would always do them underneath like this, because this is the key too. That and that. Those two make 7x. These two make negative 1x. And what does 7x and negative 1x make when you put them together? 6x. And I honestly don't even know yet if that's what I wanted it to make. I'm going to just write down what it made. It made 6x. I look up here and I go, oh, I got lucky. It actually worked. Do you get, seriously, I just guessed. What if I had guessed wrong? Well, it wouldn't have come up to positive 6. If it would have come up to negative 6, then I know I did my signs wrong. Like the plus and the minus here, these are the signs. If it ever is the opposite of what you wanted, change the signs. And if the number's ever different than you wanted, change the numbers around, the 7 and the 1. But the only time you ever change the signs, these guys, the only time you ever change these signs is if you got the opposite of the number you wanted. I got exactly the number I wanted, positive 6x. So I did it right, and I get to just leave that alone. The last number to check it is to go 7 times negative 1, and what's the 7 times the negative 1? Negative 7, and I just made sure that it worked. I did that one really slow, I know, but the final answer was x plus 7 and x minus 1. Now, can I just reverse those signs around? No, you'll get the opposite of what you wanted. If I said x minus 7 and x plus 1, it would not work, because then I get negative 6x and positive 1, and that gives me a negative answer. I mean, negative 6x is the final answer, and that's not what I wanted. I wanted positive 6x. So you can't just make the signs anything you want. You got to be really careful about the pluses and the minuses. All right, I really am a believer that you don't get good at something until you practice it. Like if I just taught you how to box, okay? So you got to keep your hands up, because if they hit you, you're basically trying to protect your head, okay? So then you got to keep your hands up. Next thing, jab is where you like shoot your like weaker hand out fast, and you're supposed to be just like quick snap, okay? And then a hook, there is a uppercut, which is like this, okay? And that's one of your most powerful punches. And then there is a hook which goes around like this, okay? There, I just taught you how to box. Oh, I told you a bunch of stuff. Until you actually box with somebody, you won't be good at boxing. Okay, so I taught you a bunch of stuff about factoring, but until you do a bunch of factoring, you won't be any good. Same thing with a kid. You could explain how to play basketball. Until they go out on the court and bounce the ball around and actually shoot, they won't get good at it. Okay, so factor this. Make me 2 parentheses. And let's go through, what do you do first? Always first. Jackson, do you want to start? What do I put here and here? Yeah, that's how you always start. The next thing is the signs. Now, does this one, could I possibly even use only positive signs? If I use only positive signs, how am I going to get a negative answer? Now, that doesn't make any sense. Could I use both negative signs? If they were both negative, wouldn't that come out to a positive answer at the end? See how I can't use 2 negatives? Almost all the time, it's going to be 1 positive and 1 negative. So you can use logic to figure out your signs. Okay, and then the last thing is the numbers. Kennedy, tell me something that multiplies to 5. Yeah, and now where does it go? I don't even want to think about it. I just want to put it in somewhere. 1 and 5, done. Now I got to check and see if I did it right. I know the x times the x makes the x squared, so frankly, I don't even ever check that, because x times x makes x squared. I don't have to check it. But this and this are where it's at. That is really where the rubber meets the road. So 5x, that's a negative 5x. Be careful, Mr. Server. And then 1 times x makes 1x. And when I put together this and this, they better make the middle term. Did they make the middle term? Yes, they did. And I got lucky. Really, again, if I had got the wrong answer, I would have probably gotten negative instead of positive, like the opposite sign. If you ever get the opposite sign, you would have switched the signs around. You wouldn't have moved the numbers. You would have moved the signs. All right. How many of you also got x plus 1 and x minus 5? All right, good. Now, without my help, try this one. Oop. I hope this is like easy. But I also know there's some people in the room where this is literally the first time they've ever factored in their life. They come from all different paths. Some people weren't here in Minnetonka last year. Some people have never seen factoring before, so we're starting off easy. Quinn, what's the very first thing everybody has to do? X and X, good. Megan P, what's the next thing that you're supposed to do? Yes, then what did you decide on the signs? Both positives, because we only have positives in the problem. We can use all positives. EJ, what numbers multiply to 3?
1 and 3.
1 and 3. And then you'd be pretty sure you're right, but how do you check it? Outside and inside is where it's at. The outside makes 1 times x is 1x. The inside makes 3x. Put them together, you get 4x. That's what I wanted. Boom, I know I'm right. Raise your hand if you got that one right. Okay, now we'll step up the difficulty level. Ready? All right, so we're gonna write out 2x plus 1 and x plus 4. Just write that out. I've already factored it. This is like Jeopardy. I just gave you the answer. I want you to tell me what the question would have been. So basically, it's like I'm saying multiply it out and see if it worked, but we'll see what you get when you multiply it out. Hint that some people really struggle with because they're like, am I adding those? Is that like 3x? No, it's 2x times an x. Amelia, do you know what you get? 2x squared is correct. What did I say it was all about? Outside and inside. The outside makes 8x. Inside makes 1x. You can do them in your head. That's fine with me. What's 8x and 1x make? Come on. 8x, 1x? 9x. Good. And then the last are these two haven't been multiplied yet. That's 4. There. Do you get if I had given you this question? This would have been the answer. You know, you'd make 2 parentheses. How is it different? It starts with a 2x and an x. See what I'm saying? This has a 2x here, so you needed a 2x and an x. That's how you get a 2x squared. What do we do next? Signs. Do you get this only has pluses, so it has to be plus and plus? And last but not least, how do you make a 4? There was 2 choices. A 1 and a 4, or it could have been a 2 and a 2. Let's say you started with a 2 and a 2, because 2 times 2 does make 4. Then if I would have checked myself, I'd have had a 4x and a 2x. Does 4x and 2x make 9x? No, so then I knew I was wrong. Couldn't be the 2 and 2. I got to change the numbers. And I would check and go, okay, must have been a 4 and a 1. But now I'm going to just check quick. I'm going to, by accident, put it in the wrong spot on purpose. Okay? Now watch what I get. I get a 4x, and a 2x times 1 is a 2x. If I have a 4x and a 2x, it gives me 6x. I wanted 9x. So that can't be right. If I'm not even close, 4x and 9x are not even close to each other, then you just switch the 4 and the 1 around. And the 4 goes here and the 1 goes there. This is basically what we call process of elimination. You just keep trying stuff until you find it. All right, let's see if you can do one like that. 2x squared plus 3x plus 1. Make 2 sets of parentheses. It's a 3-stage process. Most of you will do step 1, which is figure out what this and this are. Most of you are going to be like, well, that's easy. You just did one like this. And most of you are going to know what sign goes here and here. And then once you have that, it's not too hard to figure out how to get a 1. Multiplying 2 numbers to get a 1. You can do it. Who had 2x and x? Raise your hand if you had that one right. Good. And then who had plus and plus? Raise your hand if you had that one right. Okay, good. And then there's only one way to make a 1. It's 1 times 1. Can you just be for sure that it's right? Not until you check. 2x times x makes 2x squared. Cool. Outside and inside. This part I'm going to use blue. That's where it's at. Did that work? Because if that worked, you're pretty much gold. 2 times 1 is 2x, and 1 times x is x. And I put them together, I get 3x. Yay! Because the 1 times 1 is going to for sure make 1. That's it. 2x plus 1, x plus 1. Raise your hand if you had that one right. Cool, that's even more complicated factoring than we even have to do today. So, that's how you factor. Now, why do we even care about this factoring? What is it good for? Watch how healthy and happy this is if you know how to factor and you can get to this. I now know the two x-intercepts. In like 5 seconds, I can go, 8 is one of the x-intercepts. You see how I got that? And -2 is another x-intercept. See how I got that? So my parabola has to go through those two spots. And it took me like a half a second to know what the x-intercepts are. That's what factored form is good for. It tells you these spots. And those spots have 4 names. They're called x-intercepts, roots, zeros, and solutions. So on the ACT, they typically will ask you for those. That's one of the things you have to be able to do on the ACT. And how would you get it? You would have had the original problem of x squared. I'm going to just multiply it out in my head quick. Minus 8 plus 2 is plus 6x. Nope, minus 6x, Mr. Sir. Undo. Minus 6x. And minus 8 times 2 is 16. That would have been the original question. It gets factored into this, and I instantly know the two x-intercepts. That's what this is really good for, is x-intercepts. Okay? All right, pre-taught you everything, so now this should be easy. Go to this slide that says warm-up. Do you see the vertex? To me, my eyes just jump right to it, and it's at what, comma, what? Be bold, say it. 3, 1 is correct. That's the vertex. Next up, the axis of symmetry. I called it the axis of symmetry. Ian, do you remember it?
Sorry, I don't have this one.
The,
1 second. Let me take a look at my iPad. 3.
yes, what 3 though?
X equals 3.
There we go. X equals 3. And the vertex was 3, 1. And now the increasing interval. I think it's increasing right there, because as I read from left to right, it's increasing. And that's all about the x's. So it's from 3 to when does it stop increasing? Never. So how do I write that? Infinity. I'm fine with you saying inf, or you can say a little sideways 8. And on this, I said parentheses are preferred, but I would have accepted brackets because there's some debate about whether or not you use brackets or parentheses on these intervals. Increase or decreasing interval, this hurts some people's heads. They see this up arrow and they're like, it's increasing. Not when you go from left to right. Think of it if you were skiing down it. That would definitely be decreasing right there. You'd be going downhill in that whole red part. So where does it start? Well, kind of way to the left, negative infinity. And when does it stop decreasing? Remember, this is about x values, so 3. Parentheses, I would have accepted a bracket on the 3 for increasing and decreasing intervals. Okay, so there's all the old stuff. This is standard form, that's where it's not factored. This is factored form, that's where it's factored. And then we'll spend a whole day on this thing called vertex form. That's this. We'll do that later. Not leaving yet, but right, this is just telling you about how to multiply things out. I think this is too easy for you. Do you guys get how to just do that times that and that times that, right? I mean, do I have to practice that? I don't feel like we have to practice that. And if you had to multiply this, I know you know how to do this times this, this times this, this times that, that times that. I think you've foiled enough that you're good at that. All right, so then why do we need factored form? It's because it tells me these things. If it's factored, see, I know that x minus or plus 2 and x minus 4, once it's factored like this, it's so obvious that -2 is the x-intercept. It's what makes that part 0. And 4 is the other x-intercept. It's what makes this part 0. All right. And find this page. Got about 2 more minutes, maybe 1. See how fast you can go. What makes this part 0? Say it. -3. What makes this part 0? -2. Those are the two x-intercepts. What makes this part 0? Negative 5. What makes this part 0? Negative 3. Those are the two x-intercepts. See, if I was going to graph it, it would go through negative 5 and negative 3. And then it would be a parabola. It would look like that. So it really helps you graph them if you know those x-intercepts. But this one's different. It's impossible. I can't do it because it looks different. Now, what is it? 6, and what's the other one? What makes that part 0? 0. If I put a 1 in, that doesn't make it equal 0. But if I put in a 0, so when they're like that, the way to make it 0 is to make x equal 0. The way to make this 0 is to make x equal 6. See how the answers are 6 and 0? I know, it's different than the others. That doesn't mean it's like super hard. Okay, this is kind of hard. But watch what I do. I go 5x minus 1 equals 0, and then I solve it. Isn't that like a super easy equation to solve? It is. This one. 2x plus 7 has to equal 0. Isn't that like the easiest equation ever to solve? We just subtract 7 from both sides and divide by 2. So that's what you do. I'll finish this. 5x equals 1. Stay still. We're not leaving quite yet. Negative 7. X equals negative 7 over 2. And x equals 1/5. Those definitely are the hardest ones. But you set them equal to 0 and you solve them. And those are the x-intercepts. All right. It is about lunchtime. Okay, as we're just coming in from lunch, I want to remind you what we just learned. Say I give you this. That is called standard form. And that's not factored. Okay, stay focused. We have work time in just like a minute here. Focus, focus. So if we want to have a reason for this, it's because I get the y-intercept super easy. This one, you can't tell the y-intercept super easy. But if I factor it to this, minus 7 and plus 1, I know some of you could have done that if I'd given you the time. Then I get my two answers are x equals 7. What do you mean the answer, Mr. Server? It's the x-intercept. And x equals negative 1. Those would be the two solutions, aka roots, aka zeros. All right, and then right before you left, we had one more, like more complicated one, and it was all factored to this. Something like that. Well, this one I can do in my head. X equals negative 5. How do you solve that one? You make a little equation. Ian, what's the equation? I think you can do it in the front row. What do we want it to equal? That's the key. Ian in the back, what do we want it to equal?
0.
Yes. You want it to equal 0. Avia, what's the first step then to solve this thing?
Wait.
You're overthinking it. Just trying to solve an equation. It's got two little steps.
Oh.
Solved a million of them. Yep.
Inside.
Yeah, like this. Okay. And then 2x equals 5. And then you just divide both sides by
2.
2 and 5 over 2. What the heck is 5 over 2? Well, it's the same as 2.5. And that is the x-intercept. So one of them was super easy. It was negative 5. If I graphed it, it'd be like, here's negative 5. And the other one's 2.5, which is like here. And then I go, burp, the equation must go through there. That's what this is really good for. Factored form gives you the x-intercepts. There's 4 names: x-intercepts, roots, zeros, and solutions. All right, now let's actually get to the homework. So would you please open the worksheet that I assigned for today, U6L2 worksheet, and I usually can cut off 1 or 2. Find the worksheet. And Grace, can you read me number 1, please?
F of x minus 4 in parentheses, and then x minus 5 in parentheses.
Is that already in factored form? Yep, that's factored form. It's been factored. And so what do they want me to do with it? Does it say some directions? Does it say what to do?
X-intercept.
X-intercepts. Oh, so X equals, can you do them in your head without having to make little equations? I bet you can. What makes it 0? X equals 4 and 5. Those are the solutions. Those are the X-intercepts. Should be, not supposed to be super hard. The first one's usually pretty easy. Avia, read me, is there any more than just find the solutions, or is that it? We done with number 1?
Standard form and y-intercept.
Oh, okay. Standard form is multiply this thing out. All right, so I wish I would have left myself room to do that, so I'm just going to erase this. Multiply it out. So that's this thing. X times x is x squared. We're trying to find standard form. Are you in the worksheet right now? Feel like you're not. Try to find it. Savannah, help me finish this thing. X times x makes x squared. What do you do next? Kennedy, can you shut the door over there, please? Do you know how to do this? You're just multiplying it out. Don't know how to multiply it out? I bet you do if I just like remind you a little bit. There's first, outside, inside, and last. That was the first. Outside is here. Okay, I'll let you off the hot seat. Somebody else. This is not like super hard. We're just multiplying something out. Gianna, you got this? Okay. All right. Apparently I'm assuming too much here. We just go this times this. That's the outside ones. I sometimes assume you guys all know what we learned last year, but I often get surprised that we don't know what we learned last year. Okay, so this times this is the next one. Those are called the insides. And negative 4 times x is negative 4x. And then there's the lasts. And the lasts are this one times this one. All right. Glad we did this together then. So what's negative 4 times the negative 5? Positive 20. So that's how you multiply it all out. And final answer, I hope you know that these together make negative 9x, is standard form. This one's called factored form. This one's called standard form. And we already wrote the answers. I should have put them up here. X equals 4 and x equals 5 were called the x-intercepts, also known as the solutions, the roots, the zeros. Okay, so, man, I feel like sometimes I just get completely surprised. I thought you guys would be like really experienced at multiplying these out, but obviously not. All right, let's go to the next one, number 2. Let's pick on somebody else that I haven't talked to in a while. Surreal, can you read me number 2?
We still haven't found the y-intercept.
Oh, y-intercept. Okay, so the y-intercept, if you look at this, I'm hoping that's easy. Can you see the y-intercept? All right, I said it the other day when I told people the y-intercept is where x is. I said you'd say this in pre-calc all the time. Yeah, the y-intercept is where x is 0. So if I put a 0 here and a 0 there, can you see which one's the y-intercept? That one. Because when I put in x is 0, here and here, y equals, and these are all gone because you put in 0, y equals 20. That's what that is good for. So that's what standard form is good for. The last number in it is the y-intercept. Y equals 20 is the y-intercept. Okay, so let's do another one, number 2. Surreal, can you read me number 2?
X plus 3 in parentheses.
X plus 3.
Yep, I got that. X plus 3 in parentheses, and then?
Multiplied by x minus 4.
Thank you. All right, so first, again, I assumed, and 2 people in a row didn't know how to do this, but x squared, and then you do outside, inside. Max, you know how to do this?
Yeah, what?
I'm just asking. So this times this?
It's x negative 4,
Yep, and this?
3x.
Yep.
Negative 1x.
Yep. And then the lasts?
It would just be negative 12.
Correct. Nice job. X squared minus x minus 12. That is called standard form. And I, again, didn't know that you guys hadn't seen this in a long time, apparently. It's called first, outside, inside, last. These are the firsts. This is the outside. This is the inside. And this is the lasts. And sometimes people call it FOIL. Okay. That gives you this standard form. And I just said it a second ago, so I'm going to feel like I'm losing my mind if you don't know this. The y-intercept would be which part? Yep, that part. That's the y-intercept. Because it's where x equals 0, and you put a 0 here and a 0 there, and they just disappear. And you get y equals -12. If you wanted to write that, since y-intercepts are where x is 0, you could write 0, -12. That's kind of fancy. Not many people would probably do it that way, but this is pretty common. Y equals -12. That's a y-intercept. Guys feel like you get this? Okay, the biggest thing of the day was factoring, though, and I'm guessing that the third question will ask you that. We'll find out, though. Liv, can you read me number 3? Dang, it's not yet. This is already factored. And then, does it say equals 0, or does it say y equals, or what is it equals? F of x. Okay, so now, this is pretty obvious. It's x equals -6. If you've done enough of these, those come like natural. I did do one like this, but a lot of you didn't know. Do you know this time? 0. Your two answers are -6 and 0. Those are the x-intercepts. Now factors, these all haven't needed factoring so far, but now it's got to be number 4. It's got to be a factoring problem. Is it finally a factoring problem? Quinn, would you read me number 4?
F of x equals x, and then in parentheses x minus 10.
It's already factored again. Too easy. Seriously? They don't make you factor anything? Good Lord. I don't know who wrote this, but it was a bad idea. They should be making you factor, because that's the thing you guys are the worst at, and it's going to come up on the test. Who knows? Maybe there's going to be a number of questions like tomorrow, on tomorrow's homework or something. All right, so x equals 10, and x equals, what's this one? 0. Yes, I did, but I didn't multiply it out.
Only did 2 standard or y-intercept. That's what I'm just
Okay,
saying.
okay, I understand. But by now, please tell me you'd know how to multiply this out. Like, I knew you guys didn't know how to multiply out the other kind, but that's just distributive. You can multiply that, can't you? I feel like I'm losing my mind. 3x squared plus 18x. See, you could do that yourself, can't you? 3x squared plus 18x. All right. Okay.
Wait.
You have to finish it yourself. This is your assignment. I'm helping, but like you can finish it yourself. If you want the y-intercept, remember to set x equal to 0, and you can do your own. It's really easy. If you want the y-intercept, you set x equal to 0, and you can do it. I'm just trying to help you with the ones that are weird, and I think you might not know how to do, but you can do y-intercept. Set x equal to 0. Okay. So back to this one, if I wanted the y-intercept, I'd set x equal to 0. I could put it right there, or I could multiply it out first, which is this times this, and this times that. All right, I feel like now I'm helping too much. So this is the part where you need to get to work, and how many problems are there total?
8.
All right, I usually have you skip one, so out of tradition, I'll have you skip number 8. So you at least skip one, and the rest of the assignment is yours to do. And you even have a long day. You've made it to the end. We'll be out of here in about 12 minutes, and you'll all be able to go home early and stuff. It's wonderful. It's the end of a snow day, or I guess early release day. And that's all I have for the video for today.